Hello, I'm Nobby Clark. Welcome to my workshop, and this is part 2 of machining a toe clamp for my fixture plate. But I'm actually using the fixture plate to set this part up. This is the part we're machining here, and I've got it, the fixture plate mounted in the vise. I've got the part clamped in position. I'm using a couple of dowel pins to rest it onto, and a couple of my original toe clamps here to fix it in place. I've marked on the top here the centre position. I don't think you'll be able to see that, but I've marked it here, the centre position of the plate here, which is 2 inches long. And in the collet here I've got a larger pointer, and I use that to set up the centre position here. So what I've got to do now is replace this pointer with an end mill and machine into the face of this part here. Now I've locked the X movement of the milling table, and I can now bring down the end mill. This is a 10mm end mill. Unlock that in place, and now I've got to machine into this to cut in a feature into the front of the toe clamp. Obviously doing this very gently, because this is not I guess you would say, a conventional milling operation, and I guess you're putting a lot of side pressure on the end mill. I know you use end mills to sort of face off the end of material, but this is probably maybe putting on a little bit more pressure than it is normal, but I think it's going to achieve the result I want, is this this sort of scalloped feature on here, which I think that is going to be deep enough for what I want. Just measure that carefully and see where that's. Well, yeah, that is the measurement that I'd actually planned, so I guess that's fine. So I can take this all down now and give it a bit of a clean up, and then move on to the next part. This is a really nice end mill. It's a 10mm, and it's a Dormer brand. From my memory, Dormer was is a British company, but their products are made in lots of different countries. This particular one is made in Italy, and I have some really beautiful Dormer drills, a set of them, that I treated myself to at a model engineering show a few years ago. And strangely enough, they were made in Brazil. But anyway, this is one of a few end mills that were given to me, and this is most of them were absolutely brand new, including this one. And I've used this the 10mm one a few times now. There was also a 6mm one, and I actually used that to cut the slot here. So this is quite a precious item for me when I've not got any other end mills of these sort of quality. All the end mills that I've bought in the past have been basically import ones, which really was all I could really afford, because I did need a couple of sets of them. I've got them in metric and imperial, but they do the job, but of course they do wear out and need replacing. But this one's really beautiful. The next operation is to drill some countersink holes, or countersinks rather, into the holes on both sides, deep enough so that the tiny 2.5mm screws will seat just below the surface. The ideal thing is, once you've drilled the first one to the depth you want, is then set your the depth stop on your bench drill or milling machine, if you're doing it that way, so that you get the holes roughly the same depth on all the holes. I found quite often countersinking holes is that sometimes you end up with a rather poor sort of ragged edge. It's almost like sort of, I guess perhaps you would say like chatter in the countersink. So the way to get round this is if you set the countersink bit up to the right position. You can sort of clamp the material in place. And when I'm doing that using my finger plate to do this, which is the ideal method really. And I'm putting it so that the back of the finger plate is touching the column of the drill, save if any danger of the thing spinning round. And then cutting a small piece of cloth, ideally a piece off one of your wife's best handkerchiefs is the ideal thing. I'm going to switch the machine on, and it looks all rather dangerous. It's spinning the piece of cloth round. And that will give you a countersink with a very, very nice finish to it. Again, that screw will go very, very nicely into position. It's a very, very old trick, this, and when I was reminded of this method from one of David Ticehurst's videos, but I remember doing this many, many years ago, and it's obviously an old sort of method of drilling. I remember my father showing me this, and it's used very often if you're just drilling holes into very, very thin material, and it stops on very thin material, it's stopping the drill, or in this case the countersink, from sort of grabbing, and in this case giving you sort of rather a bad finish. But a simple thing like that works really well. I didn't actually use my wife's handkerchief. I've got this large piece of old bit of an old bed sheet, I think this was, which is ideal for that. That will make thousands of these to machine them out. So I've just got to drill countersink one more of these, and that is that part finished then once I've done that. Well, that's that part completed now. Release the part. I put this bit of scrap material on here so that I'm not clamping over that feature I've already machined on the spread. I just throw some air into those holes just to clean them up. So that's that job done. And again, another great use. I know I keep talking about this finger plate, but it's such a useful thing to have for so many different uses. And if you look back at some of my older videos, I explain a lot about the fixture plate and all its features. But it's a great project to make one of these. You can obviously make it like I did, make all the parts yourself, or you can actually buy a kit to make one of these from a British company called Hemingway. I believe they sell their tools in other countries, or certainly they're available in America. But it's I opted just to make everything myself because I wanted to. Anyway, could sort of now move on to the other features of my little toe clamp now. The next job is to machine down some parts to 1/2 inch in length. Now I've done this many times before, and the method I used was to face off one end, which I have done already, and start machining the other face, and then take it out of the chuck and measure the length to work out how much more I need to machine off. But this is quite a lengthy process, and keep having to take it out of the chuck each time I guess is not the ideal method. Now when I put it in the chuck, I've got to put it in so at least it's only a very small part, but at least half of it is in the chuck, so that it's held in quite firmly into place. And the ideal thing would obviously be able to measure the part while it's still in the chuck, enabling you to keep the cutting tool in the same position all the time, just moving it back slightly, so that once you've measured it, you can make an adjustment without having to keep resetting the tool position again. Now, it's not unfortunately possible to use one of these digital calipers, because you literally can't get the caliper back against the chuck enough. This part here is obviously too wide to get behind the part. You could only do that by literally gripping the part itself almost at the edge of the chuck jaws. But what I've got is another tool that should make this job easier. It's this micrometer. These are called anvil micrometers, also known as a unimic. And with this, I can actually get the measuring part here behind the part. It obviously, this will only go in as far as the jaws allow, so you're only actually measuring off a small part of the face. But I have done this before, and it does actually work quite well. So I'm going to use this to measure the part. Let's just measure it before I actually start. So I've got quite a bit to take off. I reckon if I take off about 50 thousandths, I'm getting sort of close, ready for the next measurement. So I can bring the tool in, ready to sort of touch off. Now what I can do is bring the tool back out of the way without changing its position in relation to the surface here, and I can get the micrometer behind the part. Let's move it round so you can see what I'm doing. Get that round behind here, and then take a measurement. I reckon I've got about 29 thousandths to come off. You see that the tool will come back into contact here. So I'll take a bit more off and would then make another measurement. Take another measurement. And we can machine a bit more away. see that, but I'm just about spot on there. I'll take the component out and switch the machine off. I'll take the component out now and measure it, obviously outside of the chuck, just to see how well I've done. Bear with me just a second while I do that. I hope you can read that. I'm actually about 5/10 over, which I'm quite happy with. I'm not going to try and get it right on the 500,000. I'm not going to push my luck actually, but I'm sort of more than happy with that. Just to show you the anvil mic again, even if you're not familiar with these, it's I suppose they call it also a uni mic because it can do a number of things. This has got a ground flat piece of steel here, and that can be moved around, or it can be brought up and down for different sort of positions if required, but it can also be removed, and if you can see this, it's held in place in this little space here, and in the center of that there's another tiny cutout which enables you to insert a round part as well, so that can be popped in there and then locked in place. You've got this little locking screw here. I haven't got that quite in position properly. Anyway, lock that in, and this then enables you to measure the wall thickness of tubing. Actually, not got that quite in square enough, but there we go. So that can go inside the piece of tube, and this then will measure the outside. So it's got, you know, obviously more than one function. This is a Mitutoyo one, and the other mic I was using there is also a Mitutoyo. This is quite an old model. This one is obviously missing something from here. I presume they were the little plates with the name on, probably in plastic, so that you hold it here and that acts as a sort of an insulator, so that, you know, heat from your hands doesn't influence the reading. Although with the tolerances I'm working at, that doesn't really matter too much. And these are also very nice because if I can actually, if I move that up to the end here, that part of the thimble is actually the ratchet. See, so that as you move out, that comes in and that part spins. Where on the other type, obviously your ratchet is on the end here. I just thought I'd show you that if you've not seen one of these before. I was lucky. This was actually given to me as a gift, and this is because it's got such a sort of a narrow section here that obviously fits quite nicely against the back of the chuck, enabling you to get it behind pieces of material. But there is obviously a problem if you're machining a piece of stock which is very small in diameter, because obviously with a small diameter the jaws are going to be brought in even further, which would mean you can't get the micrometer actually behind the part. I mean, this part I can just about get the micrometer on the edge, which is good enough. So I mean, I'm quite happy with that. You know, sort of 5/10 over is, for me, is absolutely fine. So now we can move on to another part. I've mounted one of the pieces of round stock in the milling vise. It's already been machined to 1/2 inch wide, and what I want to do is to mill a flat on the top of this piece here. It hasn't got to be too precise. The aim is to mill it so that the width of it is about 6 millimeters wide. You know, that's fine. So it's almost exactly 6 millimeters wide, in fact. Now, so we move on now to the next operation. Just raise the milling cutter up out the way. We've noticed that, I guess that as well as mounting the piece of material in here that I milled the flat on, I also need to drill a hole through the centre of this, and I've put in the other end of the vise here another piece of material exactly the same diameter, 10 millimeters. In fact, that part came off this bar, so they're identical in size. For one, it obviously helps, I guess, sort of with just a small part in here, sort of pressure on the vice jaws, although if this was in on its own I would have put it in the dead centre. The other thing is this gives me a means of using my edge finder to measure off to find the centre by using the half function. So I can bring the centre finder down, and then we run this across. Let's double check that. So I can raise that up and bring that over the other side. Take a measurement off the opposite side now. And 0 the Y, press the half function, raise that up and move that across now until I zero the DRO. So that brings me now over the dead centre. So I've just got to remove the, before I do anything, is to lock the Y movement so that nothing can move. That's it. All the way along so I can get the edge grinder out. And replace, obviously, with a drill chuck and sort out my drill size and everything else. I've replaced the edge finder with a drill chuck. I've got a mark here in the centre of the length of the piece, so I've just got to move that along. Microphone gloves, so you can get that into the centre. That's it. I'll replace that with a centre drill. Replace that with the drill. I'm drilling this to a 6mm hole size. Cutting oil, flood of cutting oil in fact. Sit on this way. Jolly good. So that's that done. Let's take the drill out for safety. So that's it. So we've got our part drilled, so that just needs a bit of deburring. There we are. We saw that I finished machining a flat on this part and then drilling a 6mm hole through the centre. But if you look at that close, you can see I've made a complete mess of this part. I believe I know what I did wrong. Well, two things that I did wrong. One was I've not got it in the centre of the length of the material. You see it's set off to one side slightly. Obviously I not got the pointer exactly on the line that I put on the material. The other mistake, I'm pretty sure what I've done wrong is that I'd mounted this in the vise with another longer piece of the same diameter material sticking out the side here, so that I could use that with the edge finder on the DRO. And I think, well, I'm sure what I've done wrong is that when I brought the edge finder down on each side, I'd not got the ball of the edge finder in exactly the same position, if you like, on both sides, and that's put the hole more to this side than the other. Stupid mistake to make. I guess what I should have done was had perhaps a shorter piece of material, so that when I was using the edge finder on one side, I could have brought it across that way and around to the other side. What I did was measured on that side and then lifted up and down, and that's where I think I've made the mistake. The bar I put in here was quite long, and I wasn't sure that I could actually get the edge finder right the way down and around and back again without changing the Z height. In reality, for what I'm making, it wouldn't, I don't think, make any difference actually. It's just that it looks dreadful, so I am going to make this part again as punishment for doing it wrong. Now, also, when I made the toe clamp itself, I showed these parallels that I've made, extra thin parallels, enabling me to easily drill the various holes in the toe clamp between the parallels without damaging my good parallels, basically, because these could still be classed as sacrificial if necessary. But I didn't think these would really be any good for this particular job, because I just thought they were a bit too thin, and my other parallels would be too wide, and for sure I would clip the parallels definitely as I drilled through here. So I was in the local DIY store a couple of days ago, and I noticed that they've got a big display there of all sorts of shape, sizes and so forth of aluminium and of steel, and I spotted that they had this material. This is 78 thousandths thick, and basically virtually the same width as the steel parallels, just a fraction narrower. So I bought a length of this. It comes in a 1 metre length. It's very, very inexpensive, and this could also be sacrificial as well. So I cut 2 bits and machined it to 3 inches wide, so it fits in the vise nicely. One problem is that when these bits are in the vise, they do, if you're not very careful, tend to tip over. And I thought that my spring clip, because of this is only 10mm wide, would be a little bit difficult to get that between them to hold them apart. So I used an idea that John of John's Workshop suggested to me, using, well, and somebody else also mentioned using a bit of foam rubber between the two. John suggested using the rubber off old earbuds. Well, this is one of the earbuds off my ear defenders. I had to replace them the other day because you see they've picked up this peculiar mould or something, probably being in my damp workshop, but then that can be put between the parallels and that will hold them quite nicely apart. So useful tip there. And when I have used bits of foam rubber in the past, but that's sort of quite a good idea. Save you know, just throwing these away when they get damaged on your earbuds and so forth. But the other sad thing is, because I drilled the hole in the wrong place, of course, Nobby has clipped one of the parallels here. See? Never mind. I mean, these and these I'm going to class as being sacrificial anyway, and I've got plenty of this now. 6 inches, less than a yard of this material, so I can make some more of these. When I got the material home, I did measure the width of it, and it's amazingly accurate. It's absolutely perfect. So I haven't bothered to machine the top and bottom of the sides of these, rather just going to leave them as they are, and it worked fine to hold that part in position. And 2 other bits that I've had to machine flats on as well. These don't need the 6mm hole through them, but they will have some other holes drilled in them. So I've got 3 there of all different sizes. I thought I wanted just to share that, you know, just to show that I've made a terrible error, but I will put it right, and obviously that's something I've got to be very careful of in the future. I should have known better, really, because I think it's the first time I've used the edge finder like this. But normally the material is not usually very long, and I arrange it so that a little bit sticks out the edge of the vise here, so that I can get the edge finder onto one side and then just draw it round to the other side to measure off. So I've not had that problem before, but I'll make sure I never do that again. Anyway, admitting my mistake is the best thing to do, and now I can sort of move on to the next part of the project after I've made another one of these, of course. Well, I machined the flats on the 2 pieces of round stock, and you saw me, well, I think, drilling one hole in one piece. So I drilled holes in both pieces, 2 holes in each, and now I've got to tap these holes 2.5 millimeters. This is my little tapping jig. I've shown this before in an earlier video, but basically what I need to do is put some cutting paste on the tap, and then bring that down and guide that over the hole, and then very, very carefully tap the hole. It's spinning now, so at least I've got the tap well and truly started. I can release that, bring it up out of the way. That can be locked up out of position, and use my little T-wrench to complete the tapping process. Let's see if I bring that forward a bit. Is that still in view? Yep. So I can carry on tapping the hole now. Is actually through, but I'll make sure I take that right the way through. There we are, that's the first one. I'll only show tapping one hole because it's just a repeat process on all these parts, but I'll bring you back towards the end of this. Well, this is the assembly of the part. I've already fitted one piece here, and just got the other bit to fit. Probably got my fingers in the way, haven't I, to stop me from seeing what I'm doing. I'm sure by now you've got a very good idea of what I've made here, but I couldn't keep you guessing right to the very end. Right, let's get those in nice and tight. Well, there we are. I guess all is revealed here. That part fits in here, so this can be attached into my fixture plate, and that will give you the sort of rolling movement here. It'll be actually around, probably that way round, like that. And now, being totally honest as I can reveal prototype number 1. I thought I'd make one of these already, just the sort of prove the idea to myself that this would actually work, and it did. So I thought, well, as it worked out okay, I can make another one to show you. So this is obviously one of the original toe clamps that I made, one of these. But I thought this would just be fun to make one like this, a sort of a miniature version. I mean, I've seen clamps, very large clamps like this that people use on really big milling machines. They're generally a cast metal version of this, probably about the size of this whole fixture plate, in sort of like, if you look, sort of like a banana shape. So one end of the casting obviously sits on the table of the milling machine, and the other side can be used to clamp down onto the material. And I think some of them have the sort of a swivelling joint on the ends here. But I thought I opted to make this. I actually made this one, the second one, if you can see that, just a little bit longer. I thought that would, be worth making it slightly longer. Whether I'm going to make any more of these, I don't know. When I was machining these parts, I did make extra ones, which I've not machined flats on or drilled them, because you can only drill them once you've made that part, because you've got to transfer these holes into that part. So I don't know, the mood may take me perhaps one day to make another one of these. I don't know, perhaps I will. Let's see if I can actually get that one attached into here just to show you. So that can be screwed in, and then by sort of releasing that, you can see you've got sort of plenty of movement for various heights of material to go in there. When I originally made this, I did clamp down quite a large piece of material, so it would accommodate quite large bits of material as well. And obviously you can clamp down these flange nuts as well to hold the pot. Well, I've only got it on one end to clamp those parts in nice and tightly. So I hope that was of interest. It's quite a fun project, quite a few frustrations along the way in making it, but I found it sort of quite enjoyable. I quite like working on quite small items, actually. So anyway, I do hope you enjoyed that. I was able to show you quite a bit of the machining involved in making, well, that one, not that one. Anyway, I'll just wind this video up now. Well, that's it from me. I hope you enjoyed this project. I had to split it into two halves because it was getting very, very long, and I think this second half has ended up being rather long anyway. But I hope you were able to sort of follow the whole project through. Again, thanks to all the subscribers to the channel, and if you haven't subscribed, please do. And obviously, if you can send me a comment, I'd be very grateful. Any sort of help, advice or whatever, or comments, please pop them in the comments. Anyway, thanks very much for joining me again, and bye bye for now.